moved on and we're never going to look at again. Everything we do from here on out is going to embed elements of those into our problem solving. Okay, so today we're going to talk about scope. Scope is a pretty critical aspect of JavaScript because once again, it's everywhere, and you've already created scope, so you just weren't aware of it. And so because of that, it's something that, it's very pervasive and you really can't avoid it when you're writing JavaScript. So it's really critical that you kind of know what's going on behind the scenes, or at least be very clear about what's going on behind the scenes at all times. Okay, so let me just get the slides underway here. Okay. Shoot. Okay, great. All right, so we're going to talk about scopes and the different kinds of books. The different kinds of scopes, including global, functional, and block. We'll talk a little bit about hoisting and kind of what it means, and then we'll end on talking a little bit about scope best practices. Today's problems are going to be, I would say, not difficult, but they're definitely going to be confusing. And as one of the things that you'll see us do quite a bit throughout this cohort is we're going to take things that, maybe when you're coding by yourself, you just kind of always assume that it worked. And we're really going to drill down to why they work and the details behind it. Because unless you know that, and so if you don't know that and you just kind of keep using it, blindly assume that it's going to work, one day it's not, and it's going to cause problems for you. Yeah, okay, cool. So scope. So the very simple definition of scope basically is that it refers to which variables can be accessed by your code at a point in the code. The other way to think about scope, really, and the analogy I can make, it's almost like a sandbox. Like if you're in a sandbox, if you remember when you were a kid or when kids were playing, right? Like the things in the sandbox are theirs, it's free to use, it's accessible. And for the most part, things outside of the sandbox are not accessible, right? So scope can almost be thought of as a boundary, as a container for saying, hey, everything in here, this is all your playground. Everything out of it, do not touch, or you do not have access to it. So let's take a look at what we mean by that when we talk about code scope. Here on line 4, I create a variable called wow, and on line 5, I print out that variable, and when I do, it prints it out, no problem, very straightforward. Now, however, so here on line 5, notice how what I'm doing here is that I'm actually console logging out this variable called wait for it. But on line 7, you'll see me actually define the variable wait for it, and we're setting it to the screen here I am. And on line 9, we actually print out wait for it again. So we'll talk. So a large part of this, we'll talk about this in a little bit when we talk more about hoisting. But essentially, this is kind of the one fundamental thing we want to talk about when it comes to scope is not just, or rather the two things we want to talk about when it comes to scope is, one is where do people have access to certain variables? And the second one is also when do they have access to certain variables, right? Here, based on what I've done now, on line 7, I've clearly created a variable called wait for it, and I said to the string, here I am. On line 5, when I'm printed out, I get undefined, right? So it's not throwing an error, it's just saying, hey, you haven't created it yet. But on line 9, I actually get the real value. The line 9 one kind of makes sense, right? It's the same as the previous slide. But line 5 is where it gets a little bit tricky. And once again, we're going to talk about this in a little bit. Okay. When we talk about scope, for the most part, most scopes, when we talk about it, it basically means where, or rather, the perimeter of the scope is more or less going to be confined to wherever we see open or closed curly braces, right? So here on line 5, notice how the happy function ends with an open curly brace. That means the happy function function's scope starts on line 5 and it ends on line 8 because there we see the closing curly brace for happy function's opening curly brace. Okay. One really key thing to know about scope is whenever a scope is created, it means that everything inside, everything in between those curly braces, things in between those curly braces are able to access the variables that are created in between those curly braces. But things outside of those curly braces or things outside of those scopes cannot access the variables created in between those curly braces. So what I mean here, On line 6, notice how in the happy function, when we run that function, we create a variable called message, right? And on line 7, we console log out that message. Now, on line 11, notice how I'm also console logging out message, but I get two very different answers, right? On line 10, when I run happy function, line 6 runs, then line 7, and I see my message, I am so happy. However, when I console log out the variable message on line 11, I actually get an error, right? And that's an error that we've discussed before. It's a reference error, which means that, hey, you're trying to use a variable that you haven't created yet or it does not exist. And so on line 11, what JavaScript is telling us is that, hey, this variable called message does not exist. And so this highlights a very key fundamental aspect of scope, which is that scope, if you think of it as a parameter, it means we are able to access things inside of it, but outsiders cannot come into our scope and access our variables. Put it another way, in this case, anything outside of the happy function is not able to go inside happy function and access this message variable that happy function created. So in that way, happy function is actually very secure because, once again, everything that they create, everything that's being created inside the function can only be accessed inside the function. No one else can go into happy function and access those variables. Now, when we talk about...
Okay, question.
Yeah, go ahead.
I have a quick question. Why did it say reference error message is not defined as opposed to the previous slide where it just says undefined?
Yeah, so we'll talk about, so like in the previous slide, it has to do more with hoisting, which we'll cover, I think, near the end of the lesson. But in this case, just think about it this way, right? Right now, one way to think about this is imagine if everything inside imagine if everything inside happy function was a black box. Oh no, I skipped over one slide. Okay. Imagine if I'm outside of happy function, imagine if everything inside of happy function was a black box. I can't see inside happy function. If I try to use a variable called message, I don't actually know what's inside happy function, and more importantly, I don't have access to what's inside happy function, right? So if I black out lines 5 through 8, and I just do console log out message, then I get a reference error, because essentially what JavaScript is trying to do is when JavaScript looks for a variable, it will look for the variable in its own scope first. And so let's take a look what that means. Okay, here on line 3, we have a variable called message, and we set it equal to the string think globally. On line 5, we create a function called log a message. On line 6, we create another variable called message, and we set it equal to act locally. Now, on line 9, we console log out message, and the question becomes, which version of message gets printed out, right, on line 9? Is it act locally or is it think globally? And the answer is, whenever a JavaScript tries to access a variable, it will always start in its own scope first, okay? So on line 9, when we're trying to console log out message, what JavaScript does is, the first thing it asks the first thing that JavaScript asks is, okay, which scope am I in? And the answer is, I am in the logs a message scope, because that's where the nearest set of open and closed curly braces are, right, on lines 5 and 10. So then JavaScript asks, great, if that's my scope, is there a variable inside that scope called message? And in this case, there is. It's on line 6. And so at that point, JavaScript says, great, let me use that version. You can almost think of it as JavaScript looks in its own home base. It looks in its own scope first, and then it looks outside the scope for that variable. If it finds it in its own scope, then there's no need to look elsewhere, right? It found it. It can move on. If it doesn't find it in its own scope, then it looks outside of its scope, and we'll talk about how that sequence works too, okay? But for now, just know that when you, in this case, when you have multiple instances of the same variable, what JavaScript will always do is it will always look in its own scope first, and then it will look in the next outermost scope, and then it will look in the next outermost scope, all the way until you get to what we call the global scope. And the global scope can almost be thought of as just the page. Okay, so if I go back to, so Martha, to answer your question here, when I go back to this question here, right? Hoisting aside, if I take a look at whether or not the variable wait for it exists in the scope, the answer is yes, it exists in the scope. Okay, but if I go back to this, if I go back to this example here on line 11, when I try to console log out message, well, if I try to console log out message, Here on line 11, it's not in a function, so we say it's in the global scope, right? It's on the page as a whole almost. It's like in like the highest outermost scope. On line 11, when JavaScript looks for the variable message, it says, okay, what scope am I in? Well, I'm in the global scope. Okay, great. Do you have a variable called message? And the answer is nope. So then that's when we see the reference error, right? So the reason why we get this reference error here is because as far as JavaScript is concerned on line 11, that message variable does not exist anywhere, including the outermost scope, which is quote unquote the global scope. In the example on this page, on line 9, when we console log out message, we look in our own scope first and we find it on line 6. So then we move on. And then for some reason that slide got stuck. Okay. So then, however, if I remove that line 6, right? Here on line 3, I define a function called message. I define a variable called message, define a function called logs a message. Okay. And notice how on line 5 there, right? And this is very tricky, we did this intentionally, right? Notice how on line 5, logs a message function takes in this parameter called message. And so on line 6, when we do a console log out message, what we're really doing is the first thing we're doing is we're asking log message is, hey, do you have a variable called message in your scope? And the answer is yes, we do. It's whatever was passed in. So on line 9, when I invoke logs a message and I pass in the string act locally, essentially what I'm doing is here, and I'm writing this out more for demonstration purposes, but it's almost like here there's like a mini thing I run that says, hey, let message equal, and in this case it's act locally. Okay, and so because of that, on line 10, when I do logs a message act locally, on line 7, when I console log out message, I print out act locally. Okay.
Steve, what if that argument act locally was not in that call to that function?
What if that? Okay, so I think that's, you mean, let's see. Okay, maybe not. All right. So your question is, what if this doesn't exist?
No. What if the argument act locally wasn't in the call to the function?
So you mean like this? Is this what you're asking?
Yes, that's what I'm asking.
Yep. Yeah. So if in this case, then remember what happens when a JavaScript is expecting an argument, but we don't give anything. JavaScript doesn't break or freak out. It just says, "Oh, I'm expecting an argument. You didn't give me one, and so therefore, in the meantime, until you do give me one, I'm going to use undefined as the argument." So to prove this out here, let's go to the repo really quick. If I was to go here and I paste it in this code and I got rid of these weird printing things, right? If I was to run logs the message and I don't pass anything in, then basically what JavaScript would do is says, hey, I expected a variable and you didn't give me a value, so I'm going to say that your value is undefined. And so when I console log out message, I'm going to console log out undefined there.
Okay, great. That makes actually it makes sense. Thank you.
Yeah, great. Yeah, so that's just just keep in mind, the whole point is to keep in mind that, remember that, when your function has parameters, like the way that logs a message function has message parameter here, those do matter. And in this case, that matters a lot because when we try to look for a variable in our own scope, the parameter variables are quote unquote part of that variable or part of that scope. Okay, so now if we actually take a look into nested functions, this is where we can kind of see the gradual kind of layering of the scope search a little bit more clearly, right? On line 2, we have a variable called global bar, and we set it equal to global. On line 4, we have a function called outer, and on line 5, we have a variable called inner var, and we set it equal to, we have a variable called outer var, set it equal to outer. On line 7, inside of that, we have a function called inner, and inside of that function, we have a variable called inner var, and we set it equal to the string inner. Okay. Now, the question becomes, when we run line 14, what happens? Okay. One of the best ways to do this is for us to actually go through line by line and actually trace through and run this program, or at least verbally talk to this program like we are the computer. Okay. So how would that look? Well, if I was a computer, I go through line 1, okay, comment. I go through line 2. All right, I create a variable. I create a variable global var set equal to the string global. Lines 4 through 12, I'm not as concerned about just yet because nothing's being run, right? I'm creating a bunch of things, but hey, who knows if I'll ever use it. Line 14 then becomes the first line of code I actually execute in terms of running a function, and line 14 takes me all the way back to line 4. Okay, so I go from 1 to 2 to 14, and now I go back to 4. Line 4, the function doesn't take in any arguments. And then when I run outer on line 5, I create a variable called outer var. On line 7 through 10, I do nothing, because even though I'm creating a function called inner, who knows if I'll ever use it. But on line 11 is when I actually run the inner function. So then line 11 takes me back to line 7, and then 8, and then 9. Okay. On line 8, I create a variable called inner var. On line 9, I console log out global var, outer var, and inner var. Okay. So what happens when I console log out global var, outer var, inner var? Well, let's take it one at a time. When I console log out global var, what JavaScript does is it says, okay, great, what scope are you in? I'm in the inner function scope. All right, great. In the inner function, do you have a variable called global var? And the inner function says, nope, there's no global var in between lines 7 through 10 that's being defined or created. Okay, so then it says, all right, if I can't find it in my scope, whose scope do I go to next? Well, you go into the next scope out, right? Think of it as an onion, right? Like if you're in the middle of the onion, like you will go to the next layer out and the next layer out, right? So what we usually call that is we call it the parent scope, right? So if you think about the parent-child relationship, when we first start off in our own scope, that's our own kind of home scope, if you will. But then if we don't have it in our scope, we'll look in our parent scope. And so the parent scope is basically, hey, this function has been created. What scope does that belong to? So another way of asking it is, what scope does the inner function belong to on lines 7 through 10? Well, that belongs to the outer function that extends from lines 4 through 12. So then great, is there a variable called global var in the outer function scope? And the answer is no, there's no variable called global var in between lines 4 through 12. So then we say, okay, well, do your parents have a global scope, right? And the outer function would then say, well, I don't have a parent scope. I'm on the outermost scope, and my parent scope, if you will, is just the global scope or the window. And so the last thing JavaScript does is say, okay, great. Well, does a window or does a global scope have a variable called global var? Yeah, we do. On line 2 there, we created. So then on line 9, the global var that we use is the global var that's on line 2. If I do the similar exercise for outer var, JavaScript once again asks, is there a variable called outer var inside the inner function between lines 7 through 10? And the answer is nope. Okay, so then the next question is there a variable called outer var in between lines 4 through 12 in the outer function? And the answer is yes, on line 5. And then lastly, the inner var that we want to use on line 9, if we go in our own scope and say, does a variable called inner var exist? The answer is yep, it's right there on line 8. And so when I console log out those 3 variables, I get back global, outer, and inner. And hopefully, it's a little bit hard verbally, right? But hopefully you kind of follow me as I talk about where we locate each one of those variables and kind of which scope we're looking into.
Question.
Yeah.
Okay. Does full stack immersive program ever go over the execution context and the variable environments to map this out, or it just gets skimmed over?
No, we'll talk a lot more about this when we talk about constructors, probably.
Okay.
Yep. Oh, cool. Was that it?
Yes.
Okay. Okay. Cool. Yeah. Yeah. Like I said, the bootcamp curriculum is meant to be more of a kind of crash course and almost like here's like the bare basics of this concept. Like everything that we've talked about, including coercion, including loops, there's infinitely more we could dive into, right? But just out of the necessity of time, we're just like, okay, these are the basics. This should help you get at least, in a good place in terms of understanding how they work from a very fundamental level. Cool. So this is what we call a functional scope, right? Because notice how all the curly braces here, these are all defined by functions. Every one of these curly braces is defined by functions. And with nested functions, once again, nothing changes. So here, there's another example, just like the last page, except now, notice how on line 8, we're constantly logging out collision. And even though there's a collision on line 2 in the global scope, there's a parameter called collision on line 4 in the outer function. And there's also a variable called collision on line 7 in the inner function. On line 8, when I console log out collision, once again, JavaScript just says, okay, great, let's start with my own scope first. Does my own scope have a variable called collision? Yep, we do. It's there on line 7. And JavaScript just says, great, use that. We never check the one on line 4, and we never check the one on line 2, because there's no need to, right? We check in order of priority. We stop once we find a value that we can use, and we go in order from our own scope first, and we move gradually outwards up until we get to the global scope. If we are not able to find a variable in the global scope, then at that point, that's when that's when JavaScript throws a reference error and says, hey, you're trying to use a variable that does not exist. And so in this case, and these slides I'm going through pretty quickly because they're all more or less the same thing. We're just changing one line at a time, right? Here on line 7, we try to use the collision variable. We say, does the inner function scope have it? Nope, it doesn't have it. Great. Does the inner function's parent scope have it? Well, the parent of the inner function is the outer function, and that scope does have a variable called collision on line 4, which is a parameter, and so therefore we are able to use that and print out the keyword outer. Right, because on line 12 we invoke the outer function with the string outer.
Okay, I think you went too quickly on this one because I had a question on this one.
Sure, go ahead.
Okay, I asked Khalid and he was about to answer, but he got distracted, I guess. But line on statement 12,
Yep.
outer gets invoked
Yep.
with an argument outer.
Yep.
So then we go to line 2. It doesn't do anything because that's okay. No. From line 12, we automatically go to line 4.
Yep.
Okay, and that one has a collision. Oh, I see what you're saying. So it has a collision. It looks for it in its scope. It doesn't find it, so it goes to the global scope, and it finds it the variable global in quotes.
No. So on line 7, when I use collision, or when this function uses collision, the first place it looks for is between line 6 through 8, and it doesn't.
No, but wait. I was looking at from line 12 to line 4.
Okay. Yep.
See what I mean? Because why would I be on line 6? That function hasn't been invoked.
Right, but when you invoke outer, right, you have to invoke line 9. It's unavoidable.
How can you walk me, like, for instance, line 12, then you go to line 4, and then from line 4 you automatically go to line 9?
Well, you go through lines 5, 6, 7, 8, but these 3 lines, like, not like you're creating a function, but you're not running it. But on line 9 is when you actually run the inner function.
Got it.
And so all I'm saying is, if you're running the outer function, you can't not run the inner function, because running the outer function implies you're running line 9.
Right, that makes sense. Okay.
Yep.
Okay, because although you're reading functions on line 6, you're reading that function definition. That doesn't mean you're actually running it. You're just going to the next line until you can run something.
Right. So on the first pass through, we create this outer function on lines 4 through 10, but we don't run the outer function until we get line 12, right? Like if I remove line 12 here, the outer function never ever runs. Right? It only runs because on line 12 I actually invoke this outer function. Similarly, on line 9, if I remove this inner function, this inner function will never run. Right? It only runs because I actually invoke it there on line 9.
Okay. So basically, just to refresh and just so I can get this slide, because I was reviewing this before class. Okay, so let's invoke it from the beginning, from line 12. Then you jump to line 1. It doesn't really mean anything.
No, you go from line 1. You always start at the top of the page. You go from line 1 to line 2, and then lines 4 through 10 you're creating something, but you're not running it. And line 12 is the first time you actually run something. So when you run something, then you go back to where that thing was created. In this case, when you run line 12, you go back to line 4.
Okay, so we go to line 4, and we see that the function outer has a collision variable. It looks for it in its local scope. It says no.
No. It's not looking for the collision variable. It's creating a variable called collision. Oh, oops, didn't mean the caps. Let collision, and it's equal to, I'll put it kind of in English here, whatever was passed in, right? And whatever was passed in was outer.
Oh, okay. Collision. Okay, right. Collision is the name of the parameter for outer in quote.
Yep.
Outer. Okay, collision is the parameter for the string outer. Okay, so then it has outer, and then it goes to, it says, hey, okay, I read you function definition 6, I read you 7. Okay, now 9, I'm going to invoke inner, and then it goes, jumps back to line 6, where it's an anonymous. No, it's not anonymous. It's just an inner without a parameter. And then it goes to line inside, goes to line 7. And at that point, it wants to print on the console log the parameter, whatever was passed in as parameter.
It wants to console log out the variable collision, and so the next step it tries to do is it tries to find the value for collision.
Okay, and so because it's not in that scope, it looks into its parent scope, and that's where it finds outer.
Yep.
And not global.
Yep.
Okay. Thank you.
Yep. Great. Okay. Any other questions?
No, thank you.
Cool. Cool. All right. So then, once again, and this is just like the last example we'll kind of do in this framework, right? If there is no variable called collision except for the one in the global scope, then hey, we'll look in inner first. We don't find it. We'll look in outer next. Don't find it. And then lastly, we look in the global scope. And once again, we do find it there. And if we didn't find it there, then we would have thrown the reference error. Okay. Notice how one of the things I've talked about, and this is hopefully makes one of the first slides a little more clear, right? Is as JavaScript, I'm able to start with my own scope, and I can work outwards my parent scope. But I cannot look inside other people's scopes that I'm not a part of. Okay, and so what does that mean? Well, so here, if you notice how in the outer function, I create a variable called outer var on line 4, and then I create a function called inner, and in there I create this function called inner var equals inner. On line 8, when I print out outer var and inner var, the inner var I get from my own scope, and the outer var I get from my parent scope. Okay, that's on line 8. On line 11, however, when I try to console log out inner var, the only scope I have access to is my quote-unquote outer function scope. And because scope only works in one direction, you can only look in one direction, which is more and more outwards, it's almost like the outer function cannot see what is inside the inner function. And so when I try to console log out inner var on line 11, what JavaScript says is, okay, you can't look in between lines 6 through 9, but other than that, does the variable inner var exist in your own scope, which is lines 3 through 12? And the answer is no. So then JavaScript says, okay, great, let's go up to your parent, which in this case is a global scope, and ask, does the global scope have a variable called inner var? And JavaScript says, nope, didn't find it. So then at that point, that's when JavaScript throws us the reference error, okay? And so as important as it is for us to know that, hey, I can look in my parent scope, it's also important to know that I cannot look in my child scope, right? I cannot look in the outer function in this case, cannot look in the scope of the inner function, nor can I look in the functions of any of its sibling scopes, right? Sibling scopes just mean that, hey, if I happen to have, sibling scope just means, hey, if I happen to have another function parallel on the same level as me, right? So, I'll say, I'll call this one middle. This just means that, hey, the inner function can look in the outer scope, but it cannot look in the middle function scope because these two are quote-unquote siblings. They're in the same level. They each have their own scope, and you can look inside yours, you can look inside your parents, but you can't look inside your siblings, and you also cannot look in the scope of any of your child functions.
That's why I think it's so nice that ES6, ECMAScript 6, added the default parameters to avoid this, right? Is that why this was to avoid the hoisting and avoid this mass confusion?
It's useful in some cases. It contributes to confusion in other cases. So like it's like a tool, right? Like it's like, is a hammer nice? It's like, well, yeah, if I need to hammer a nail in, it's great. Right? If I have a bunch of screws, it probably makes things harder and not easier. Okay. So as with anything, right? I'll say that for the most part, like these things that are introduced, like they're clearly introduced for a reason, right? People want to use them because they're shortcuts for things that can be quite painful. But then there are use cases for the original ones. So yeah. So in any case, so the takeaway from all this is that you can scopes can look outwards, but it can't look in. It cannot look inwards, and it cannot look side to side. Okay. So, and I'm sorry to kind of keep beating you all over the head with this, right? But same exact idea here. If I was to look at what outer var is in this case, well, once again, if I'm on line 9, when I console log out outer var, I'll say, do I have a variable called outer var in my own scope? And even though on line 7, it's quote unquote, it's there, it's undefined, that's the one I go with, right? I see on line 5, I have a variable called outer var that's has a perfectly good string value, but JavaScript doesn't care what the value is, right? JavaScript just cares, hey, does this exist? And so on line 9, when I print out outer var, do I find it? Yeah, I found it. Great, I'm done. And we move on, right? And even though that value is undefined, so what? Like, I looked in the first place, and even though I don't like the answer, it is what it is. Okay. So far, all of those scopes had to do with the curly braces we see from functions. But we also noticed that we've seen a lot of scopes being created by curly braces used in loops as well, right? And these include while loops, if loops, or I guess not loops, but while loops, for loops, and if statements. And so in ES6, one of the things and one of the reasons why we use the let keyword is because let doesn't really care where the scope is, whether or not those curly braces are attached to a loop or an if statement or a function. It says, hey, whatever variable you create with the let keyword, it only exists within those curly braces, right? So here on line 5, we use the let keyword to create this variable called block, and we set it equal to a string. On line 6, we console log out that variable called block, no problem. On line 9, once we're outside of the if statement, guess what? Same concept from before applies, right? We cannot look in our child scopes, and so therefore, outside of lines 4 through 7, no one can see any of the variables that were created in that if block, and so therefore, when I try to console log out block on line 9, I'm basically just asking is, hey, does the variable block exist on the global scope? The answer is no, so then I throw back a reference error saying that variable is not defined. Okay, so this is what the let keyword does. The main difference between the let keyword and the var keyword, which you might have seen, is the var keyword creates a variable and it only ties it to the nearest function scope, which means it only ties it to the nearest scope, or the nearest set of curly braces that are a part of a function. The let keyword, on the other hand, will tie it to any curly braces, even if it's attached to a function, an if statement, or a for loop. And so you can think of the let keyword as being a bit more restrictive in that way, right? Like if I have an if statement and I create a variable inside of it using let, it means I can only use that variable inside of that if statement. If I create it with var, it means I can use it in an entire function, even if it's outside of the if statement. So that's kind of the main difference. For the purposes of our class, we'll predominantly go with let because it is, generally speaking, in programming in programming, you want to be as precise as possible, and using let is actually a really kind of good precise way for you to figure out kind of which variables belong where. Okay. Any questions so far before we talk about hoisting, which will be kind of our last major topic before we cover some best practices?
David, I had a question on the slide before, well, not that one, the one before. Yeah, so that returned undefined and inner, correct?
Mm-hmm.
So is it correct to say that if it can find a variable in its scope, it will use that and it doesn't replace it with something else, right? Like,
yep. Yep.
Thanks.
Cool.
Okay, I also have a question on the following one, the one that the var
Sure.
inside the function. Okay, that one confused me a little bit. I understand the let is restrictive and doesn't let you, it's kind of stingy, it doesn't let you share the variable.
Yep.
But why is var so generous? I don't understand. Is var the same as saying it's a global parameter or a global variable definition?
No, not at all. I mean, the main difference, if I think about it this way, right, is that's just undefined. So okay, so then let me just go through and make this example here. if I just do console.log out, let's say like, let's create a variable, okay. In this case, if I say, hey, let David equal food, right? This is going to give me a reference error because it's going to say, hey, I tried to use David. I can't look in this scope here, so I couldn't find the value called David, and therefore therefore David gives me a reference error. Okay. If I use var here, nothing changes. Same like I did too, right? Once again, console.log says, hey, I'm trying to look for David. I can't look in this scope here, and therefore David, the variable David, does not exist anywhere on this page, and therefore I'm going to throw back the reference error. The only difference here is that if this is saying in if statement, which we saw before, if the if statement has this now, well, now it makes a bit more of a difference, because now if this if statement says, hey, if I create a variable with var, it means that this David variable now belongs to this logs a message function scope, and so anyone inside of this logs a function message scope has access to David. So my console log here on line 5, when I print it out, oh, I forgot to invoke log message. Oh, I can print out foo, but if I make this instead of let equals David, then that means this David variable is only tied to lines 2 through 4. It's only tied to the nearest curly braces finds, which in this case is the if statement. And so on line 5, I try to console log out David. I get back once again the old reference error because there's nothing in this logs and message scope that has a variable David, and I can't count this if statement because this is considered a child scope. So that's the only difference, is that if we're dealing with only functions, then nothing changes. But if we're dealing with curly braces coming from if loops or from if statements or for loops or while loops, then the let keyword only lets you create variables that can be used within the confines of those loops.
And as a practice, when you use if loops and while statements, do you use let or do you use var?
Well, it's not a matter of kind of best practice. Oh, so okay, sorry. As a best practice, you should be using let. Kind of, like you should only be using let. There's no instance in which there's really no instance in which you should be using var now. Using let might be a little bit more tedious and might cause you a little bit more work, but the idea is that the security and like kind of the precision that affords you is worth it, and actually makes your code a bit easier to read. So in general, you should always be using let for everything. Yeah.
Is it also a fair statement to say that whenever we receive a reference error message, it means that variable, that parameter has been defined, but it just can't access its scope because it's locked? It's scope locked somewhere?
No, because I can make this something like Martha, right? Yeah. And now it says Martha has a reference error, but it's not created anywhere.
Oh, okay. I thought it was a quick shortcut.
Yeah.
Okay.
So the computer doesn't tell you why it can't find it, or if it finds it somewhere else. It just says, hey, from where I am right now, I can't find it. That's pretty much it, for any reason.
Thank you.
Yeah. Cool. Any other questions? All right, just a few more lessons, a few more slides here, and then we'll get started on the workshop. One of the things from the very first slide we talked about was I mentioned we're going to talk about is this idea of hoisting. So hoisting is actually a pretty interesting concept. The thought process behind hoisting is almost like, well, before JavaScript kind of goes through an entire page of code, it actually goes through that page of code twice. The first time it goes through the page of code is it actually makes a note of all of the variables and functions that are kind of created on the page. And then the second time it goes through that page of code, it actually executes each line of code. So the reason why that's important for us to know is because if you look at this example here on line 6, we create this function, we call this a function declaration, right? We create this function, will this work? And we console log out yes. On line 4, we actually invoke this function, quote unquote, before we create it on the page. But because of hoisting, the first time JavaScript goes through this page, it says, oh, on line 4, I'm going to run something. Okay, whatever, it doesn't matter. I'll do that on the next run through. On line 6, it says, oh, this function, will this work? This already exists. Let me make a note of it. Okay, so that's the first run through. On the second run through, it then says, okay, great, will this work? Let's run it. do I have a, or do I already have I already seen this function before? And the answer is yep, I saw it during the first run through. So now on line 4, I can actually run will this work successfully. So even though to our kind of human logical sequences, it feels like the will this work function is defined after it's being run. The fact that JavaScript actually goes through this code twice, the first time what it does is, and the reason why I call it hoisting is hoisting means to lift, right? And so the reason why I call it hoisting is because it's almost like JavaScript takes these things and it lifts it, it hoists it to the top of the page. So it's almost like when we run through this code again on the second try, the will this work function is actually located on the very top of the page. Okay, and so if we talk about kind of the difference between like a function declarations versus a function expression, there actually is a difference. And so on line 6, right, notice how this looks, line 4 is the same as before. We still invoke this function called will this work. But now on line 6, rather than having a function declaration, we actually create a variable we call will this work, and we set it equal to a function. Okay. The main difference here now is on the first run through, when JavaScript reads this code, the only thing it hoists, if you will, is the acknowledgement that there's a variable called will this work. It doesn't assign a variable to will this work just yet. Okay? It doesn't assign a variable to will this work just yet. So on line 4, so when we actually, on the second run through of will this work, notice how it's not a reference error, right? That error we get, it's not a reference error, right? On the second run through, it doesn't say, hey, will this work is not a real variable and it doesn't exist. It actually acknowledges, hey, it exists, but I don't know what value it is, and so I can't invoke it because I don't know whether or not it's a function, right? And so once again, this is kind of one difference between declaration versus expression, is just that when you do this, then when you do an expression, just be aware that JavaScript won't hoist the entire function up to the top of the page. It will only hoist in this case, the name of the variable.
So is this case the same thing as saying, so in this case, the computer created the variable will this work, and it's uninitialized.
It's
right?
undefined.
Undefined. Okay,
Yep.
that's fine. Okay.
Yep. So on the second run through, when you get to line 4, will this work is a variable, but its value is undefined. And so when you try to invoke undefined, it will throw an error saying, hey, oh, in this case, we'll throw the type error saying, hey, I can't invoke it. This is not a function. Right. It's only until we get to line 6 in which now we then replace undefined with, in this case, the actual function that console logs out no. And I think there was a question in the beginning of class about like, oh, should we always use arrow functions at all times? And like there are ways to get around it, right? But if you were to use an arrow function, then you would be using a function expression, which is what we see here on line 6. And if you were to use an arrow function, then you can't do, for example, this thing here, right? So once again, right, like these things are for the most part just tools. Like the things that are like kind of more hard and fast rules, like we should be using let instead of var, I'll tell you about. But for the other things, like when to use an arrow function versus when to use a function declaration, a lot of that is more dependent on kind of the use scenario and kind of what you're trying to do. A lot of cases it actually won't even matter. It's up to the programmer's choice, right? It's up to your personal style as to which one you prefer to use, one versus the other. But generally speaking, like there's nothing. It's not like one's good and one's bad. It's just they're tools to be used under different circumstances. Cool. And so just to wrap up this session, and I'll open up for more questions. Some best practices. Generally speaking, you shouldn't change global variables inside functions, because even though you could, even though you are able to, notice here on line 2 we have this variable called always true, and we say equal to true. On line 4 we have a function called don't mind me, and it actually changes the global variable always true to something else. And so therefore on line 10, by the time we use always true, we actually don't even know what the value of always true is anymore, right? And so this is actually like a new, not new, but this is like a very common issue, is that, think about it, if all, let's say 17 of us, if all 17, let's say there was like a piece of cake, right? Like in a box, and all 17 of us had access to that box. Well, by the end of the day, like someone could have eaten a piece of cake, but maybe like we don't know about it, right? Like we don't see the person modifying it. Same thing applies in this idea here, which is that like if you have a global variable, one, it's always risky to use a global variable because for this very reason that other people can change it. And two is, generally speaking, don't change global variables. Global variables are meant to be global, and they're usually meant to be they're usually meant to be read only, like as in like use the value but don't edit it. For this very reason, right? That like when you use a global variable, you don't know who else. Well, you know that everyone else has access to it, so you don't know who actually changed it before they or while they were using it.
So is that why it's better to just use const when it's supposed to be not changeable at all times, or or that doesn't matter?
No, yeah, no. Const is something. Const has more to do with like with mutability. Um, or at least in my opinion, const has more to do with mutability. As in, like, const doesn't let you redefine a variable, but it does still let you quote unquote change certain variables. Actually, it's a little bit of a confusing thing, and we'll talk more about it when we talk about arrays and objects. But you are able to change the value of const. Um, okay, right? So like, and just so you guys don't think I'm just like saying that. Um, if I have, for example, or actually let's do const, foo, right? And I set equal to an array 1, comma 2, comma 3. And then here I do a console.log out foo. I see my 1, 2, 3. But then if I do foo dot push 4 and I console.log out foo again, notice how my foo changed even though I use const, right? So const doesn't mean like it's permanent, it can never ever be changed. It just means you can't redefine a variable. And we'll talk about the difference between changing a variable versus redefining it when we talk about pass by reference versus pass by value. Cool.
Yes, thank you.
Yep. Cool. Awesome. Okay, great. So this is why usually if you need to use a global variable, or sorry, if you need to use a variable that's named after a global variable, just make your own version of it, right? There's no harm in that. So on line 5, rather than saying, hey, let's change always true to false, let's just create our own variable called always true and set it equal to false, right? And now whenever anyone inside don't mind me tries to use the always true variable, well, like I said before, we're going to look at our own scope first, and we'll always use the version that we create as opposed to the global version. Oh, that's too fast. In general, you should almost never use global variables. Very few things actually need global variables, and typically speaking, global variables are seen as kind of like an unavoidable last resort that should only be used in the most desperate of situations. And if any programmers see global variables, they will do their absolute best to get rid of it, however possible. The reason why is because if you have a lot of global variables, and one, people don't know where it is or what it's called. Two is, once you have a global variable, if you try using it, it's just not secure. And so there's a lot of different like downsides to global variables and very few upsides. The other kind of concept in programming is that every function should only know just enough to do what it needs to do. And so it's very unlikely that you have a variable that every function needs to know. So global variables in general are just bad practices. And actually, I think a lot of code editors have stopped letting you do this now. But a shortcut to creating a global variable, I'm not sure if REPL is on this bandwagon or not, is to actually just create a variable, but don't use let or var or const. So if I just say foo equals foo bar, that just creates a global variable automatically because I didn't preface that variable with any kind of I'll say like variable creation keyword. But let's check. Like, this is such horrible bad practice that a lot of code editor just like even like they will mark that as a warning or mark it as an error or at least a warning. Let's see if REPL lets you do it. Okay, so REPL doesn't let you do this anymore either. So yeah, but if you do see something like this, then that just means that person is making a global variable, which also is something that generally they should just not be doing to start with. Cool.
And just to use that REPL example that you just created,
Mhm.
uh, that's really technically that's not a running function, correct?
The David function is not. Oh, you're absolutely right. I never ran David. That's a good catch.
Okay.
Great. Okay, yeah. So okay, I guess
Okay.
I guess REPL does let you do this though. In this case, we created a random data function. We create a global variable called foo, and here we're accessing it. So REPL does still let you do this, but you shouldn't, right? Like this is just really really bad coding practice. Yeah, good catch. Cool. So that's pretty much it for this session. No one a bit over on time, but almost a full hour actually. Um, any questions?
When I've seen like I have a tutor, believe it or not, because I'm getting tutored for JavaScript so I can do well in the interview, and she does that. She does the what you just said not to do. How do I politely tell her as a student, don't do that,
Oh,
without sounding, condescending?
I would just ask her like, oh, is there a reason why we're making global variables instead of making this a locally scoped variable? Um,
Okay.
and I think I mean, like I said, right? Like at the end of the day, everything is all of these are just tools, and so and you'll see this a lot, even in job interviews or coding interviews. Actually, people will always ask you to defend your choice of why you chose one thing over the other. A lot of times, it is a matter of preference, but people at least want to know that they want to see that you've thought about it in a meaningful way. And so if your tutor is using global variables, ever just ask her like, oh, like what's the benefit of using global variable, and say like, like, but what if someone else edits a global variable, or like isn't it unsafe? And I don't know, maybe the problems that you're working on, she has a good reason to use a global variable. But I know that like in real production systems, global variables are universally kind of seen as bad form.
Thank you.
Cool. All right. Any other questions? Cool. All right. Like I said, sorry.